Hello, everybody. We are looking today at the Topic 6 test review. Topic 6 test review, and problem number one is asking us about. Uh, problem number one is asking us about some variables. It wants us to solve for both of these variables. Actually, the first couple of problems are all doing that same thing. And this problem right here gives us a pentagon, and it's got one exterior angle. So we're going to first look at the pentagon itself, and the equation. The way the pentagon sets up is pretty similar for just about all the problems that are like this. Okay, what we're going to do is we're going to take angle plus angle plus angle plus angle plus angle all the way around the whole entire inside of the shape, and just add it all up and create an equation where all of those things added together is on one side of the equal sign, and on the other side of the equal sign is the number 540. Now the question is, where did this 540 come from? Well, it came from taking the five sides and subtracting 2, so we get 3, and then you multiply that 3 times 180. That is exactly what the formula in our notes said to do to find the sum of the interior angles. The sum of the interior angles, according to our notes packet, is 180 times n minus 2. Well, n on a pentagon here, n is going to be n is going to be 5. So 180 times 3, that's where this 540 came from. After you get it to right here, it's very simple. All we're doing is going to combine like terms. So we've got all these constants and a couple of variable terms right there, and it combines all down into that. Okay. Then after that, it's just solving the equation where x is throwing a party. We send home the friends and then send home the family members, and x equals 10. Now, the next part that we're looking at is solving for y, and y is this exterior angle right here. And when we're looking at this, we already have that x equals 10. Okay. The other thing we need to know is this right here, 13x plus y plus 10. Okay, our interior angle plus the exterior angle equals 180. Okay, the reason for this is that those two angles are a linear pair. Okay, they both, this angle right here and this angle in here, both have this leg of it in common. But when you put the other two parts together, it forms a straight line going across right there. Okay, that is a linear pair. And a linear pair adds up to 180 degrees. So that means this 13x plus y plus 10 equals 180. After that, again, we already know what x is. X is 10. So that becomes 130 plus y plus 10. All right. After that, it's just solving for y. So we get x equals 10 and y equals 40. Go on now to our next one, is more of the same, except this time we've got 6 sides. So on one side of our equation is going to be all of the angles all added together, angle plus angle plus angle, all the way around the whole inside of the shape. Then the other side of the equal sign is going to be, this time, 720. Okay, using that same formula as we did before, the sum of the interior angles on a hexagon should be 180 times 4. Okay, 6 minus 2 is 4, so it's 180 times 6 minus 2. That's where that 720 came from. All right, we move that on down, combine like terms, and then again, it's just send home the friends, send home the family members. X equals 60. On this last one, this time we only have 4 sides, so it's going to add up to 360 degrees. Angle plus angle all the way around equals 360. Combine like terms and solve. Question number 4. Question number 4 and 5 both are again asking us to find the values of the variables. So on a parallelogram, one of the key facts that we talked about in parallelograms, one of those boxes that we filled out on the notes in the properties was that the diagonals bisect each other. That word bisect, we can't forget. It means to split into equal parts, okay? It cuts it exactly in half, splits it into 2 equal parts. So that means this top chunk up here and this bottom chunk down here are equal to each other. This chunk to the left and this chunk of the line to the right are equal to each other. And after that, it's just a matter of solving these equations, okay? You'll notice on a lot of these problems in this section, there's only a little bit of geometry knowledge. The only part of geometry that you needed to know was that the two things were equal to each other. After that, it's just asking you to solve for the variable. It's just a matter of solving those equations. All right, so we move this 11 over, and then we want to move this 2x over. We subtract it over. All right, and then you divide and you get x equals 8. On this one, we're going to do much of the same thing. We move the 4 over, we add 4 on both sides, and then we subtract 1y on both sides. So 2y equals 6, 1y equals 3. And that's your two answers right there. The next problem is another parallelogram. And on both of these, on the sides of a parallelogram, one of the other properties that we filled out in our notes was that opposite sides are congruent. So that sets up two equations again. This side up here equals this side down here. This side to the left equals this side on the right. All right, and then solving the equations is the same. We want all of our constants on one side, all of our variables on the other side. All right, so this time we move over, we subtract 6m on both sides, and then we're going to add 11 on both sides. And so m equals 2. On this one, this one did it the opposite way. It did the constants first. We add 12 on both sides, and then we subtract 1n, and then divide. So there's your two answers to that question right there. All right, this next question, number 6. If the diagonals of a quadrilateral are perpendicular, what kind of quadrilateral could it be? Well, as you look through your notes, there are several times that we talked about the diagonals of shapes being perpendicular to each other. And one of them, it was a thing all by itself. It was kites. And we actually had some problems that talked about the finding the perimeter of a shape like this, and how that was the same thing as finding the hypotenuse of a right triangle. All right, so a kite would be one of them. Another one would be a rhombus. Okay, when we talked about the subcategories of rectangle and rhombus, that was one of the things in rhombus was that the diagonals were perpendicular. And the last one is a little bit tricky. And that would be a square. Okay, you got to remember that a square has all of the same properties as a rhombus. All right, so if you've got perpendicular diagonals, it could be a kite, it could be a rhombus, or you could go even more specific than that, and it could be a square. Number 7, these go pretty quick, all these questions. This first one, we've got 4 congruent sides and 4 right angles. That is a square. All right. When these questions say classify them as precisely as possible, I mean, all of these shapes have 4 sides. They could all be called quadrilaterals, but we want to go as many subcategories as we can. Okay. They could be trapezoids. They could be parallelograms. They could be this one right here. It could be a kite. Okay, within the subcategory of parallelograms, you could have one like this where all 4 sides are the same. That would be a rhombus. You could have one like this where all 4 sides are the same. And this one, see, here's the thing. When you look at this shape on number 10, it looks like a square, right? Just off the top of your head, it looks like all of those are right angles. But you do not know that. You don't know if they are exactly right angles unless it has the little box in the corner. Okay, the only thing we can say about this one is that it's a rhombus. Okay, we cannot definitely say that that's a square because the only thing we know is that we've got congruent sides. This last one right here, we've got opposite congruent sides. We've got 4 right angles. That's going to be a rectangle. Problem number 12. Okay, explain why the quadrilateral is a parallelogram based on given information. Now, here's what this means. Okay, what this thing is saying is it's asking the question, what property of parallelograms is represented? Okay, it's asking the question, how do we know that from this picture that the shape is a parallelogram? When we look at this first one, we can tell that the opposite sides are congruent to each other. Okay, we've got two marks on the top and bottom. We've got one mark on the left and right sides. Well, in our properties of parallelograms, back from those notes, it said that opposite sides are congruent. So that's what we put down right there. All right, that one's got opposite sides congruent. This next one, this one says that AE, it says that AE equals CE, and it says that BE equals ED. All right, this right here is talking about how both of those diagonals are split exactly in half. Okay, if we're taking diagonals and splitting them exactly in half, our fancy word for that is bisect, yeah? So when we talk about that, that's one of our other properties of parallelograms. Diagonals bisect each other. Our last one right here, number 14, it gives us a picture where angles are talked about, okay? If we look at our properties of parallelograms from the notes, opposite angles are congruent. Right? And that's what we have going. Opposite angles are congruent. All right, we got opposite sides congruent. We got diagonals that bisect each other, and we got opposite angles congruent. Based on that information, we could say that all three of those shapes are all parallelograms. On now to number 15. Number 15, on your paper, number 15, if I'm remembering correctly, does not give you number 15 on your paper does not give you a picture. Okay, it suggests that you draw a picture. When you're taking this on the test, I also recommend drawing a picture. All right, this one tells us that HIJK is a rectangle, so we draw it going around the corners of this triangle, HIJK. It tells us that HJ, this diagonal right here, is X, and IK, this other diagonal, is 5x minus 12. Well, when you look at your properties of rectangles in your notes, one of the things that we wrote down for a rectangle is that the diagonals are congruent. And if the diagonals are congruent, that means this chunk of it equals this chunk. All right, HJ equals IK, and that means X equals 5x minus 12. All right, same as always, put all of your constants onto one side, put all of your variables on the other side. So we're going to move over this 5x. We subtract 5x on both sides. Positive 1x minus 5x gives us negative 4. Negative 4x equals negative 12, so x equals positive 3. This next problem is exactly the same. TUVW is a rectangle, and it gives us the lengths of the two diagonals. Okay, this problem is exactly the same as the last one. All right, it tells you it's a rectangle, and it tells you that what the lengths of the diagonals are. Well, on a rectangle, the diagonals are equal to each other. They're congruent. They're the same. So we just got to solve that equation when we eventually get down to x equals 2. Problem number 17. 17, 18, and 19, we've got 3 problems in a row that are about trapezoids. Okay, trapezoid midsegments are a tricky little thing. If we remember from your notes, the equation we used was that the midsegment equals the average of the two bases. So if you take this top base plus this bottom base divided by 2, that equals this middle one right here. All right, here we go. With that right there, we've got 3x minus 2, our midsegment, and we've got our two bases added together divided by 2. Now, here's the thing. A lot of times when you're solving an equation like this, it is going to be much easier for yourself to just take this at the very beginning, multiply it all times 2. That's going to be a lot easier for you because what it does is it strikes out that right there. It leaves it to where all this stuff is exactly the same. Now, when you do that, Don't forget that you have to multiply both sides. Everything gets multiplied times 2. All right, this is just like when we solved. This is just like when we worked with mid-segments of triangles. We want to get it out of fraction format. And the way we do that is multiplying the whole thing times 2. Okay, so that denominator disappears on the right side. All we have left is 2x plus 2x, 4x, and then negative 2 plus 6, positive 4. On the left side, what we did was we distributed everything. We distributed all of that to both of those things, so 6x minus 4. All right, this one moved the 4 over, so we add 4 on both sides, and then we subtract 4x on both sides, so that x equals 4. Number 18 is more of the same. All right, it's the same exact equation setup. Mid-segment equals base plus base divided by 2. Base plus base divided by 2. All right, you multiply the whole entire thing times 2. Multiply it all times 2. You do that on both sides. And we end up like that. All right, it gets rid of the fraction and leaves everything else on top alone. This next one, number 19, again, it's the same thing. Mid-segment equals base plus base divided by 2. So we multiply times 2, and we're left with just what was on top of that fraction. This one moved the constant over first, and then we move the variable over. This one didn't come out to a whole number answer, and that's perfectly okay if you end up with a decimal or a fraction, however you want to put it. That's perfectly okay. All right, our very last problem is an exercise in logic. Mark cuts out rectangular pieces of cardboard for a project, he cuts out pieces that he believes are rectangles because he wants to check to see that they are actually rectangular by determining if the diagonals are congruent. So the question is this: if the diagonals are congruent or not, is that enough information to tell you if the pieces are rectangles? Okay, is that enough just if the diagonals are congruent to say that the pieces are rectangles? Now, we already talked about this a minute ago. On a rectangle, the diagonals are congruent. Those lines that connect corner to corner across the middle of a rectangle, they are congruent. All right, this picture right here shows us that. These two blue lines in the middle of the picture are the exact same length. But here's the problem that we run into. Okay, the problem that we run into is that there is another shape that we talked about that also has congruent diagonals. It is this right here. It is an isosceles trapezoid. All right, that trapezoid where these two sides, the legs, are the same length, those diagonals are also congruent. That's on the next to last page of your notes packet. As I look at it right here, it's on the next to last page. On an isosceles trapezoid, those diagonals are the same length. So just because Mark has congruent diagonals, that's not enough to say. So to answer this question, will this tell him whether the piece is a rectangle? No, because the shape could also be an isosceles trapezoid. The shape could also be an isosceles trapezoid. All right. On your test, it's going to be all multiple choice questions. If you're really not sure about some of those equation solving questions, I recommend testing out your answer choices. Okay, one of them has to be right. So if you can use your test taking strategies like you did all the way through middle school and in Algebra 1, I really believe we'll be okay on this. Okay, you'll notice that a lot of the questions in this whole thing, a lot of the questions really didn't involve that much geometry. Like these questions right here, the only thing you had to know about geometry was the setup of the equation. After you have the equation set up, it's just a matter of how well can you solve it. It's the same thing when you come across on like these diagonal ones. The only part of geometry you needed to know was that these two things were congruent to each other. After that, it's just solving an equation. Okay, it's general math skills. Okay, so as you go through this, use your test taking strategies and use the things that you already know about algebra to your advantage. Okay, use what you know about multiple choice tests and how to apply that stuff to this. All right, there's only a little bit of geometry. This test is really just a lot of general math skills, and I believe we can really do pretty well on this one, hopefully better than the last one. All right, so that's all we've got for this. Y'all have a good one.